Hi, welcome to Basic Operator Training for EcoStruxure Building Operation presented by E&E Systems. Let's take a look at the agenda to see what we're talking about today. Today we'll be talking about what a building control system is and what we're trying to accomplish. The system architecture, information technology versus operational technology, and the user experience, workspaces, graphic navigation, alarms, alarm handling, reading and writing variables. Some of the primary goals of a building management system are to maximize efficiency and reduce consumption, optimize occupant comfort, maintain the equipment, and respond to alarms quickly. With rising energy costs and competitive markets, controlling energy while maintaining a comfortable work environment have become critical to today's building managers. Much like the computer in your car controls the engine, controllers in your building control your equipment. Inputs collect data from sensors in the field. The controller makes decisions through programming based on the collected data, and through outputs controls the appropriate equipment. In the example of a simple air handler, we might pick up a temperature sensor in a room. The controller will take a look at that sensor's information and through programming decide to perhaps turn a fan, open up a damper, enable a chilled water pump, or perhaps turn on some DX cooling. We can then control and integrate a variety of equipment throughout the building by networking these devices together. Pumps, fans, chillers, air handlers, and other equipment can now be programmed to work in concert, as well as allow us to remotely monitor systems and alarms. A typical control cabinet could consist of a variety of products, such as a power supply, automation server, and several I/O modules. The power supply supplies 24-volt power to the system across a common bus. More power supplies can be added to meet the power consumption of additional I/O modules if needed. The automation server can deliver data directly to the user or to other servers throughout the system. It can run multiple control programs, manage local IOs, alarms, handle scheduling and logging and communications using a variety of protocols. Because of this, most parts of the system function autonomously and continue to run as a whole, even if communication fails or individual servers or devices go offline. This is sometimes referred to as standalone capability. There are 16 different I/O modules to choose from to ensure each installation can be customized to the equipment needs. The enterprise server is a central point in the EcoStruxure BMS architecture from which users can configure, control, and monitor the system using Workstation or WebStation. Centralized alarm handling, graphic navigation, and trend logging are handled here. Workstation is a licensed interface where users and engineers can access their EcoStruxure BMS servers. You can view and manage graphics, alarms, schedules, trend logs, and reports. Engineers can configure and maintain all aspects of EcoStruxure BMS from Workstation. WebStation uses a desktop web browser such as Firefox or Chrome to access and view EcoStruxure BMS servers. You can manage alarms and trends, change data set points, and override points with the proper access from WebStation. Any engineering functions, programming, and graphic changes, to name a few, must be done from Workstation. The control system can be broken down into tiers. Tier 1, also referred to as edge controllers, and Tier 2, controlled products or field bus devices. Devices such as the enterprise server, automation server, or a workstation or WebStation PC are considered edge devices. Tier 1 aggregates and hosts the controlled products in Tier 2, allowing it easier to access information obtained from these devices. Tier 2 can consist of a variety of devices and communications protocols from different vendors. Here we show the flexibility of an automation server and its ability to communicate on several platforms such as BACnet over IP, BACnet MSTP, LAN, and Network 8000 ASD. As BMS controls advance, we find ourselves using networking as a tool to connect people with hardware. If you've ever heard the term the Internet of Things, it refers to the interconnection of these network devices. Our Tier 1 or edge devices shown here connected on the information technology network, and our Tier 2 devices on the OT or operational technology network of the edge controller or device. We've learned that communication efficiency is greatly improved by managing networks this way. Sometimes there's a desire to save money by putting OT equipment on the IT network. Although this method can work, the additional traffic on the IT network has proven undesirable to many IT managers. The plant controller on the right is an example of a Tier 2 or OT device on a Tier 1 or IT network. It helps me to remember these devices on the IT or information technology network as devices in the carpeted areas of the building, and devices on the OT or operational technology network as devices in the non-carpeted areas, such as mechanical rooms or tel data closets. There's a lot of computing going on above us in the cloud and below us in the controllers. Our focus today is using EcoStruxure, Workstation, and WebStation to collect the information that we need and assemble it in a simple and user-friendly environment. In the past, it was not unusual to monitor systems in your building, such as HVAC, lighting, or fire, from several separate platforms, sometimes called multi-silo systems. Today, with device-level integration, we are bringing all the building systems together within the BMS. This data integration allows for a single access point to monitor and manage alarm handling and data acquisition. Sometimes these are referred to as multi-silo systems, and here we show it as an integrated solution. Now that we've talked a little about infrastructure, let's look at the user experience. Let's talk a little bit about Workstation. Workstation has customizable workspaces. The EcoStruxure building operation software has the flexibility to be fully customizable to the viewing preference of individual users. The main interface, called the workspace, is a panel-based interface where users can select, position, and resize a wide variety of components such as alarms, graphics, and editors. A default workspace is assigned to each user account, but users can easily modify, save, and create multiple versions to choose from. The workspace can also be modified as needed to address real-time issues. Workstation can be installed on any Windows machine and connected to StruxureWare servers using the most secure communication protocols. It is required for engineering tasks such as programming and graphic editing and requires the purchase of a valid Workstation license. Because graphics in EcoStruxure use HTML5 scalable vector graphics, there is no pixelation or distortion of graphics when zooming in or viewing from different screen sizes. Graphics look the same on all screen sizes, laptop, tablet, or phone. Here we've taken and zoomed in on one of the pumps on the screen shown in this slide. Because graphics in EcoStruxure use HTML5 scalable vector graphics, there is no pixelation or distortion of graphics when zooming in or viewing from different size screens. Graphics look the same on all screen sizes, laptop, tablet, or phone. Here we've zoomed in on the pump on this screen to give you a closer look. The workspace in Workstation and WebStation is the area where you perform all tasks at your site, such as acknowledging alarms, viewing trend logs. The workspace is made up of different components such as panes, lists, and views. These components can be configured in a number of different ways. You can hide or display components and create and save your own workspace. You can also reset the workspace layout to the default layout for the user group or user account it belongs to. In many cases, you may have a CEO or a facilities manager or occupants on a floor that want to access the system, but they don't want to look at the same screen. The CEO may only be interested in energy consumption, whereas an occupant may only be interested in the floor that they are working on. Because of these personalized workspaces, you can customize a workspace for each one. Let's talk a little bit about user management. Typical systems have 3 levels of access: modify, read-only, or no access. EcoStruxure allows you to customize access levels for different users. Windows integration using single sign-on can be used to create ease of access and security controls. It's important to note that single sign-on through Windows Active Directory must be set up and managed by the network administrator of the individual site. Alarms and events can be managed easily from WebStation. Alarms can include checklists, values, double acknowledgement, and email notification. Checklists allow you to create defined steps for operators before acknowledging the alarm. Double acknowledgement requires 2 operators to acknowledge the alarm, often used for high priority alarms. A graphic can be attached to an alarm to allow easy navigation to the equipment or the area in alarm. Alarm messages are fully customizable by color, notification, and alarm message content. Sorting and filtering allows users to quickly view or locate alarms or groups of alarms. Timestamps identify the occurrence, and count indicator shows the number of occurrences. Alarm notification uses SNMP, or Simple Network Management Protocol, for alarm delivery. SNMP is an Internet standard protocol for collecting and organizing information about managed devices on IP networks. It's important to note that a separate SNMTP server supplied and managed by the site's network manager or network administrator is required for email notification to work properly. Individual schedules can be assigned to shadow a lead schedule, allowing the user to change multiple schedules at once. An easy-to-read and manage graphical interface shown here in WebStation allows for quick editing. Events can be prioritized to override an existing schedule for a certain time period, avoiding a return to re-edit later. Calendars can be assigned to a schedule for holiday exceptions. Individual calendars can be created for multi-tenant occupancies. Schedules in WorkStation offer a similar look and feel with the addition of a combined view showing both the schedule and the calendar in one graphic. Advanced editing and management features are also available in WorkStation. Historical data logging allows us to record and store data from points in the system. Locally collected data can be sent to an extended trend log in the enterprise server, where storage capacity is typically larger. This frees up memory in local controllers like the ASP and gives redundancy to trend data. This data can be represented in trend charts or trend log lists for review later. Multi-trend charts or lists can be created to show more than one value on a single chart. Drag and drop and rollover highlight values are some of the features in a trend chart. Help is just a keystroke or click away. Using the F1 key on your keyboard or clicking on the question mark in the toolbar from WorkStation opens your web browser and navigates to the Schneider Electric help file for the screen you're currently viewing. If you're stuck with schedules, for example, simply click the question mark or press F1 and you'll be directed to the proper help file. This does require internet access and the creation of an account with Schneider Electric. An email address and password are the only thing needed to create the account, and no fees are involved. This feature is only available in WorkStation. Here's a sample of data values you may see in your system, shown here in WebStation. A typical BACnet value in its normal condition, a forced value outlined in yellow, and then perhaps a controller offline with the red X. Here are some typical alarm indicators. Here we show an analog value shown in alarm outlined in red, its normal state, and then here we have it outlined in yellow with the hand indicator indicating it's been forced. Here's a typical digital set point with options enabled, disabled, and NA. NA indicating the control has been returned to its application program. Here's a typical tri-state or floating point indicating opening, closing, or stationary, whatever position that the device is in. Here's a typical StruxureWare display value shown normal, and again here with the hand indicator and outlined in yellow for a forced value. When left clicking on a value on a screen, oftentimes this Edit Properties box will open up, depending on the type of point that it is. This is an analog point that's been forced to 65 as shown here. From this screen, you can edit the point or override it, again, depending on your access level and the type of point from the system. This concludes the presentation for basic operator training. We hope you found the information useful. To learn more about E&E Systems or to schedule a training session, visit our website at enesystems.com or use the link below.